I'm going to go to chapter 4 slides, and I'm going to share my screen. Can you see my slide page on chapter 4?
Yes.
All right. Let me start on it. We finished chapter 4, chapter 3. And basically what we discussed was bonding. Now we know what kind of compounds are formed between reaction between elements, ionic compounds and covalent compounds. And we know how to name them and their characteristic features. We're going to move on to chemical reactions. Now, little more detail of chemistry. Basically, we're going to look into aspects of chemical reactions and how you balance chemical equations and how you calculate energy from chemical reactions. First, we're going to look at chemical reaction. You should be able to write a chemical equation. Chemical reaction represented by a chemical. You guys all right? We normally write a chemical equation for each chemical reaction. There are reactants, products. So we also classify chemical reaction into three based on two categories. What happened to the atoms when they combine with each other? Some of them combine, some of them break away. Decomposition, synthesis, reaction. We classify reaction according to how atoms or the reactants come together. We also classify chemical reactions based on reactivity pattern. Some of them show precipitation. Some of them show acid-base reaction, neutralization reaction. They are mainly reaction between acid and bases. Precipitation reactions are mainly reaction between ionic salts, ionic compounds. There's also oxidation reduction reactions. These are the three main types of reactions. So we need to learn how to balance chemical equations. After we go on balancing chemical equation, we're going to go into aqueous solutions reactions. We need to predict what is formed during the chemical reaction in aqueous solution. The precipitation reaction, acid-base reactions. We're going to look into detail how to predict these reactions. Then we're going to go to oxidation reduction reactions. These are reactions where electrons are transferred from one atom to another, one compound to another. Electron transfer is oxidation. When a compound loses electron, it's oxidation. When compound gains an electron, it's a reduction. So we're going to look into that. I'm not going to talk about rest of the topics today. So if we can finish 4 sections, then we're going to look into stoichiometry, how you do chemical calculations. Now let me start with these are the These are the 9 objectives. We're going to look into that today. We will be going over. Now let me start on these 9. Chemical reaction is where one or more reactants is converted to products. Reactants are found on the left side of the reaction equation, chemical equation. Products are found on the right side of the chemical equation. Anything that react are called reactants, that produce are called products. So reactants are the starting compounds, products are the ending compounds or elements or compounds. In this chapter, we will be going over 4 aspects of chemical reaction. Balancing is important. Chemical reaction follows conservation of mass. We talked about that in chapter 1. Mass is conserved, therefore atoms are conserved. So balancing is checking the number of atoms in the reactant side and checking the number of products on the products atoms. And they should be equal, atoms should be equal. Then we're going to go over types of reactions. Reactions are classified based on pattern, how the reactants come together and what happened to the products. Synthesis reaction is when two reactants come together and produce a product which is more complex than reactants. That complex product is formed, is a synthesis. When a reactant decomposes into simpler compound, it's called decomposition reaction. Acid-base reaction is type of a reaction based on reactivity of chemicals. There are certain compounds which are called acids and certain compounds which are called bases. When they react with each other, they neutralize, produce salt and water. Those are acid-base reactions. Oxidation reaction, I talk about oxidation reduction reaction, where the electrons are transferred. Later, we're going to go into mass relationship in chemical reaction, which is called stoichiometry. So we are not going to go over these last two topics today, and also going to look into heat gain or loss during chemical reaction later. These are the classification of chemical reaction based on what happened to reactant atoms and what is going on when products are formed. First reaction is the synthesis. Two simpler, these are two atoms combined to form a chemical compound. The sodium chloride is formed, sodium plus chlorine here, two elements. Sodium chloride is formed. This is a synthesis reaction. It's also called a formation reaction. Decomposition is when a complex compound, this is a compound, break into simpler. Copper carbonate here is complex than copper oxide and carbon dioxide. Therefore, this is a decomposition reaction. Some reactions show one atom of an element replacing this green element, which is copper. Iron is replacing copper, and copper is coming out. This is called single replacement. Single atom is replaced between two reactions, two reactants. Double displacement is when both switch each other. There are swapping of atoms here. That's called double displacement. So these are based on complexity of form or what happened to reactants. These two are double replacement. Copper is where gone to replace sodium and OH is going to replace the. You can look at the pattern and identify that based on basic pattern. Pattern depends based on reactivity. Excuse me. Precipitation is when two compounds in a solution, dissolved in solution, are mixed up. One of the items is a insoluble salt. You can clearly see milkiness or precipitate, white precipitate, depending on the color, yellow precipitate. Precipitate is formed. That's generally called a precipitation reaction. Precipitation reactions are mainly between two ionic compounds. When you mix the ions of two salts, there are certain combinations which can come out of the solution because they are insoluble in water and form a precipitate. You can look into the reaction and describe the reaction based on precipitate formation. These are based on classified acid compound classified with certain properties. According to certain properties, bases are litmus. Litmus is a paper which turns pink when you put in an acid solution. Litmus paper put in bases turn blue. So this is how we identify compounds as acid-base. When they react with each other, they form water and a salt. So we also classify reaction according to oxidation reduction. One thing characteristic of oxidation reduction is electrons between two species are transferred. So you can look at the charges on the particles of atomic particles and conclude that one atom loses or gains electron. Normally, these are no charge transfer. Therefore, you can identify oxidation reduction reaction from first two. Now I am summarizing these into little more details. We started with chemical reaction. Based on basic pattern or reactivity pattern. These are reactivity pattern. Precipitation is when precipitate is formed. Oxidation reduction is when electrons are definitely transferred between atoms of the reactant. There's a definite gain and losing of electrons. Acid-base is reactions between compounds classified as acids and bases. Now this is where most of the reactions are. Oxidation reduction reaction. You look at this arrow, this arrow, this arrow. There are three types of oxidation reduction reaction, where the electrons are transferred. Combustion reaction, when oxygen reacts with certain elements, form carbon dioxide with carbon, and oxygen form carbon dioxide, is a combustion. Coal burn to produce carbon dioxide. Coal is carbon. Synthesis reactions are where reactants come together to produce more complex products. Photosynthesis is light-assisted reaction where oxidation takes place between carbon dioxide and water. Carbon dioxide and water with light energy is converted to carbohydrates. You know, photosynthesis is an oxidation reaction, oxidation reduction reaction. Decomposition is opposite of combustion. Their complex products are decomposed into simple items. This is reverse of combustion. Combustion is mainly reaction between oxygen. Decomposition is any reaction which complex reactants is converted to simpler products, where the elements involve transfer electrons, oxidation reduction reaction. Let's look into some of the questions. We are going to look at certain things we write on chemical equation. Delta, this sign, written in the top of the reactants, product. This means heat is required for reactant to go to products. Heat is generated. Heat is not generated. Heat is required. Catalyst is needed for the reaction to occur. Sometimes we put the catalyst like copper oxide catalyst, compound name, on top of the equation for catalyst. Therefore, delta is a heat. That's not the correct answer. Water is needed to reaction to occur. If water is needed for the reaction, then we put water on top of where the delta is. Heat is needed for the reaction to occur. That is the correct answer. So therefore, answer is D. Sometimes when we need light, we write down H nu. H is Planck constant, nu is frequency of the light. That's a term used in energy of light is represented as H mu. That's a photo. Light is required to carry out the reaction. Next question. Identify the correct classification of the reaction. You look at the type of the classification. This is mainly based on what happened to the reactants. It's broken down into simpler. Now this is one item here. Now it's broken down into two. That's the decomposition. Synthesis is coming together, which is not true here. Single replacement is not there. There's no replacement. Only oxygen comes. Double displacement is not the correct answer. Therefore, displacement is the correct answer. B. Decomposition. I'm sorry. Decomposition. I wrote down. Identify the correct classification of the reaction. What this could be? Could you think about, based on what I said about here? It's opposite of that. Simpler compounds, water and sulfur trioxide, go to sulfuric acid. That's a synthesis reaction coming together. It's not decomposition. It's not single replacement or double replacement. Therefore, answer is synthesis right here. Combustion is burning element or compound in air. There are a lot of combustion reactions. Main thing is fuel with oxygen. You get products plus heat. That's how you create oxygen, produce carbon dioxide and heat. And that's how you use heat to do so many things. The following chemical reaction equation tells combustion of propane gas, which gives carbon dioxide and water vapor. This is the propane. That's what takes place in your gas grill with the propane tank. Oxygen is from the air. It mixes up and you light it up. So it can get converted. Once you light up this reaction, got turned to carbon dioxide. Sulfur also burns in air, sulfur dioxide. That's another form of. Most combustion reactions are hydrocarbons, organic compounds, burn in air. This is the oxidation reaction. Oxygen, elemental oxygen, has zero charge. So that's, in a way, we're going to talk about oxidation reduction reaction and tell you how exactly you tell it's an oxidation reaction. Combustion reaction is oxidation reduction reaction. While else it tells us reactant production and there are and chemical reaction also indicate with parentheses physical state of the reactant and product. And these numbers need to be balanced. There's a number in front of propane, oxygen, carbon dioxide, and here in water. So how do you balance this one? You put a 3 here, 3 carbons. You have 8 oxygens, hydrogens. You put 4 here. Then 4 plus 6 is 10. Therefore, 5 oxygen. So these are called stoichiometric coefficients. Let's do some practical problem on balancing reactions. This is acid-base reaction. Acid is the hydrochloric acid, hydrogen chloride, calcium hydroxide. These have certain common properties which acids show up, HCl. HCl is acid. A salt is formed and water is formed. Salt is calcium chloride. So if you look at this, to balance this equation, you put a 2 in front of here, 2 chlorines. Calcium is balanced. 2 hydrogens balanced. 2 oxygen is balanced. Now, it's simply putting a 2 in front of, you don't write ones in front of in the stoichiometric coefficient in this phrase. There's a 1, we don't write. So 2 in front of HCl will balance the chemical equation. Photosynthesis is a oxidation reduction reaction. Photosynthesis, light assisted conversion of carbon dioxide to water, carbon dioxide with water to produce glucose. That's the basic photosynthetic reaction. Now, this is kind of a complex. You can see there's going to be 6 here, then 12. 12 should be right here, 12. Then that makes 12 hydrogens here. I'm sorry, 6 hydrogen. Why 6? 6 times 2 hydrogen is equal to 12. So therefore, 6 should be the stoichiometric coefficient in front of water. Now you balance the oxygen. There's a 6 oxygens, 18. There's a 6 oxygen. There's a 12 oxygens here. 6 oxygens, 18. That's 6. 6 times 2 is 12. 12 plus 6 is 18. So if you put a 6 here, 6 here, 6 here, that reaction is balanced. How do you balance this equation? This is a combustion. These both are oxidation, reduction reactions. So you start with 4 here. 4 hydrogen, 4 carbons. Then you go to the water, 5. 4 times 8, 2 is 8. 8 times 8 plus 5 is 30. So this is going to be 13 divided by 2. When you have a fraction like that, you have to multiply all the stoichiometric quotient. Therefore, 2 here, 13 oxygen here, 8 carbon dioxide, then 10 water. You normally don't leave fractions. We're going to look into some of that again. So this is the balance equation. (26). We're going to look into that. Which set of coefficients balance the chemical equation? That's what we came up with, right? Can you remember? 2, 13, 8, 10. Right? Same equation. You go over this one carefully yourself and figure that out. D is the correct answer. Reaction like this, what are the coefficients in front of reactants and products? If you look at this, there are going to be 3 here. Putting a 3 in front of CH4 make 12 hydrogens. So this is only 10. Therefore, you put a 2 in front of here. This is still, you don't show 1 here. This is 1. So therefore, answer is this. Okay. Do you guys have any question how we balance?
No, sir.
All right. Answer is D. We talked about respiration. Respiration is opposite of photosynthesis. In photosynthesis, carbon dioxide react with water to produce glucose. This is photosynthesis. Respiration is opposite of that. Glucose is burned in the cells in mitochondria, produce water and carbon dioxide, and energy in the form of ATP. How many of you heard about this? In the body, ATP is the currency of energy.
Yes, sir.
ATP use. Therefore, respiration is this. Therefore, this is not respiration. Neither is this. Therefore, answer is D. We're going to go over precipitation reactions. Precipitation reactions are reaction between ionic compounds, which we call salts, which has positive and negative ion. Ionic compounds have positive and negative ions. Some of the ionic compounds are soluble in water. We're going to look into the solubility rules to figure out which ionic compounds are soluble in water and which are not. When you mix up two soluble salts, it breaks up, ions break up in the water, and new combinations are formed. When new combinations lead to precipitate, it produces cloudiness and the color depending on the characteristic of the precipitate. For example, let's look at two solutions, two ionic compounds. This is sodium chloride. When you put them in water, they break up and goes into solution. When they goes into solution, we call ions break up. And they produce what we call aqueous ions. Sodium ion is aqueous. Chloride ion is aqueous. That AQ means now in a water solution. This solid means it's solid with chloride and sodium ions in a solid together. Now, this is interesting, how these water atoms, we call aqueous, water atoms, a lot of water atoms surrounded sodium ion and chloride ion. Look into the picture. This is sodium before going into crystal of sodium. Now they are broken up into chloride right here and purple ones. Here is the picture of sodium ion. This is the aqueous. Water has a dipole, negative charge on oxygen. Now oxygen is getting attracted to sodium here. Chloride is getting attracted to other end of the dipole of water. Chloride is negatively charged. Therefore, dipoles of the water, where the hydrogens are, turn towards the chloride. So this is what we mean by aqueous ion, sodium ion, aqueous chloride ion. All right. So these are sodium and chloride ion are found, only thing that is found on the ionic solid here, right here. Now they are surrounded by water molecules. This water molecule is called solvated ion, solvated. Solvent surrounded ion. Let's look at what happens when two ionic compounds are mixed in solution. Two solutions are mixed. Solution 1, where sodium chloride is dissolved. You also get, when you dissolve silver nitrate, in water, similar to sodium chloride, you get silver, solid silver ion, silver nitrate here, and nitrate ions. The bottom solution is, it could be either, it doesn't matter. When you assume you pour sodium chloride solution into the bottom, where this white precipitate is formed, because this leads to combinations, two new combinations. Sodium nitrate, silver chloride. Silver chloride is an insoluble salt. White color is, it's solid, has a white color. Therefore, silver chloride is precipitated. That's how you identify what takes place when two ionic compounds in water are mixed up. We're going to look into solubility rules to exactly to predict what solutions are soluble, what ionic compounds are soluble in water, what are not soluble in the water. Depend on if this is what I will be. Two new combinations, silver chloride and sodium nitrate. Precipitation reaction depend on one of the salts has to be insoluble. If both are insoluble, there's no reaction. If two ions combine to form a water-soluble compound, precipitate is formed. If all ions are soluble, no change will be observed. There's no precipitation reaction. Therefore, when you mix up two ionic compound water solutions, you have to look into combinations formed in the new solution and predict whether precipitate is formed or not. Now we are showing this again. First solution is silver nitrate. Second solution is sodium chloride. For these two reactions, you can write down several types of equations. Reaction between ionic compound, precipitation reaction between ionic compound. You can write down the reaction, complete ionic equation, or chemical equation, or molecular equation. Ionic equation shows charges. Chemical or molecular equation is, this is the formulas. Let's look at the ionic equation for this reaction, complete ionic. When you mix up these two, these are the starting material. Then you write down, these are the starting material, where it is coming from here. These are the product material combination. Out of these two combinations, silver chloride is the only insoluble salt. This is a soluble salt, therefore it remains in the solution. Therefore, when you try to write down the molecular equation, you combine these. Molecular equation is neutral. You combine ions. That leads to that leads to sodium chloride. This leads to sodium nitrate. There are two ways to show ionic precipitation reaction. Complete ionic equation, the first one. Second one is without charges. There are several other things that you describe in precipitation reaction. Another equation is net ionic equation. Net ionic equation is complete ionic equation. This is complete ionic equation. When you remove common ions, for example, nitrate is common on both sides. Sodium ion is common on both sides. They really do not participate in the reaction. Ions are still there. Only what happens was reaction between silver ions, chloride ion, and forming a silver chloride solid. Therefore, third way to show what really takes place in precipitation reaction is in terms of net ionic equation. So it's pretty easy. You look at the complete ionic equation, combine the ions, you get chemical or molecular equation. Net ionic equation is look into the complete ionic equation, remove ions that are found in both sides. Ions found in both sides are called spectator ions. Spectators does not participate. That's the meaning of a spectator. So they are not in the game. Therefore, when you remove spectators, you get net ionic equation. The simplified equation is called net ionic equation. It shows only ions that react. Ions that do not participate in a precipitation reaction are called spectator ions. It could be in different reactions. If you find a chemical equation, complete ionic equation where ions are found on reactant and product side, they are still called spectator ions. Which of the following represent the correct spectator ion in the equation? You look at the complete ionic equation. This is complete ionic equation. What are the spectator ions? The copper sulfide is formed. Therefore, copper is not copper and sulfide combined. The two chlorides here and two chlorides are still there. Potassiums are still there. Therefore, spectator ions should be two chlorides, which is chlorides, and potassium. They didn't give you two chlorides, therefore potassium and chloride. Rest of this is wrong. This is wrong. They are not spectator ions. This is correct, but this is wrong. It makes it wrong. Therefore, answer is B. Which of the following is true for spectator ions? Spectator ion forms solids, which is not true. Spectator ion forms gases that escape. We didn't talk about it. Spectator ions are, the precipitation reactions are not redox reactions. Oxidize means loss of electron. That's not true. Precipitation reactions are not involving electron transfer. Spectator ions do not participate. That's the meaning of spectator. That's the correct answer. Now we're going to go over what we said before. How exactly you will find out what ionic compounds are soluble and what ionic compounds are insoluble in water. Most of the precipitation reactions take place in aqueous or water solution. Solubility rules are there for water solution. These are rules. If you have an ionic compound which has one of these, any of these cations, regardless of what is the anion, they are soluble. Lithium of anything is lithium carbonate, lithium sulfate, lithium chloride. Do you have a question? Okay, I think it's an accident. Any salt which has these cations are soluble. Therefore, if you find lithium ionic compound start with potassium, sodium, potassium, rubidium, cesium, ammonium are soluble. Any ionic compound with the anion, these are cation-based rules. These are anion-based rules. Anything nitrate, anything acetate is soluble. You can forget about the cation. Anything acetate, anything nitrate is soluble. For other anions, these are for sure soluble. What about bromide and chloride and iodide? These are not included in the second solubility rule. We talked about sulfate, chloride, bromide, iodine, and sulfate. They are soluble, but there are few exceptions. Silver chloride is not soluble. Lead chloride is not soluble. Barium sulfate is not soluble. Lead sulfate is not soluble. So, is sodium chloride soluble? Yes, because it's under first rule, sodium. Is lead chloride soluble? No. Why? Is the exception. Lead is right here. Barium sulfate, lead sulfate. So most of the chlorides are soluble except silver chloride and lead chloride. You get a table of solubility rules. You look in the table and interpret. Okay?
This meeting is being recorded.
What's going on? I'm trying to find out what went on. Are you guys there here?
Yes.
Yes.
Okay. Somebody started recording. I was not sure whether if I was recording or not. All right. So carbonate right here, phosphate are another set of hydroxide. Last solubility rule is for carbonate, phosphate, sulfide, hydroxide. Exception for hydroxide are these. Lithium hydroxide is soluble, sodium hydroxide. Ammonium hydroxide are soluble. So only hydroxide considered, other hydroxide are considered like magnesium hydroxide. It's slightly soluble. Sulfide are insoluble, except sodium sulfide. The first rule apply first two. Then you look into the third and fourth rules. So you can figure out which ionic compounds are soluble or not. Predicting solubility of salt in water. Which of the following contains is insoluble in water? Can you tell me? Chloride, calcium chloride, soluble or insoluble? Only two exceptions, silver chloride and lead chloride. This is soluble. Therefore, it's not the answer. This is soluble. This is not the answer. Acetate are soluble. This is not the answer. If you look at the last one, carbonates are soluble except all carbonates are insoluble. Except first rule cation. Sodium carbonate is soluble. All right. Can you look at how I got the most carbonates, phosphate, sulfide are soluble, insoluble. Exceptions are hydroxides. But most carbonate, all carbonates of lithium, sodium, potassium carbonate, cesium carbonate, ammonium carbonate are soluble because it's covered by the higher priority rule. Which of the following compound is soluble in water? This is insoluble. Bromide, iodide are insoluble. If you go back, lead chloride. That for sure, this is, if you look at this, acetate, this is acetate, right? Acetate for sure is more soluble. Therefore, answer is D. When you in doubt, which of the following compounds are soluble in water, you go for most correct answer. Which of the following sulfide is soluble in water? This is not sulfide are insoluble, except group 1. Lead is not group 1. Group 1 is lithium, sodium, potassium, rubidium, cesium, ammonium ion. That's the first rule of solubility. Which is soluble is C. Which of the following anions always form soluble compounds? Anions. Nitrate, we know that. Hydroxide, there are exceptions. Sulfate are exceptions. Always means every soul. Therefore, answer is A. Which of the following anions always form soluble compounds? Anions. Acetate always form. Phosphate, no. Sulfide, no. Exceptions are there. Therefore, answer is A. Do you see how we got problems from based on solubility rules? Okay.
Yes, sir.
You can look into solubility rules and figure that out. A beaker with the image. That's kind of an image during a precipitation reaction. Remember? The precipitate forms, metal being reduced. You cannot tell whether there's a metal. Metal is not white powder. Salt is dissolving. Definitely, salt is not going into, this is adding two solutions. This is most likely is precipitate forming. A. Examine reaction takes place in a beaker in the image. Which of the following might be product being formed in the beaker? This is soluble. This is a metal. This is aqueous ion, which is in solution. This could be most likely to be formed is silver chloride. We know silver chloride is white powder, white color. Therefore, answer is B. The reaction between nitric acid and calcium carbonate produces nitrate and carbon dioxide and water. Which of the following is correct balance equation for gas formation reaction? Certain reactions, acid with the carbonate, when they react, they produce carbon dioxide and water. That's called a gas formation reaction. First, carbonic acid is formed. Then they break down to these two. What is the balance reaction? You check out the number of atoms in both sides. Which one is balanced? Water has two hydrogens. Therefore, this is two hydrogen. Nitrate is balanced. Calcium is balanced. Carbon. This looks like the correct one. But this could be true too. This is not true. Why? This formula is not correct. Do you see that calcium nitrate is this one? Now this is the correct answer. This is not the D is the correct answer. You check the two hydrogens here, two hydrogens here. Nitrate didn't break down. There are two nitrates. There are two nitrates here. Carbonate is the one broke up with oxygen here. That's correct. D is the correct answer. the product of the reaction between phosphoric acid and magnesium hydroxide. That's an acid-base reaction. These are acids. We talked about acids. Bases are called hydroxy compounds. What is the balance equation? Water is formed in all cases. You have to correct. Magnesium hydroxide is correct. Phosphoric acid is correct. Magnesium phosphate. Correct formula for magnesium phosphate is this. Why? Phosphate is 3 negative, magnesium is 2. This is incorrect. This is incorrect. This is incorrect. The only answer is this. When you check the hydrogen balance, there are 6 of them here. Phosphate didn't change. There are 2 phosphates. Therefore, water is produced 3, 6 waters, 6 hydrogen. D is the correct answer. You see, check the formula, correct formula, and the balance equation should have correct formulas and stoichiometric coefficients. All right. We talked about a gas formation reaction between carbonate. Ions in solution react with each other when one of these can happen. Form a compound that is insoluble in water. That's precipitation. Gas that escape, like carbonic acid, between calcium carbonate and nitric acid. Carbon dioxide forms, sulfur dioxide forms. They are called gas formation reactions. The bicarbonate and hydronium ion. Hydrogen come from acids. It produces carbon dioxide and water. That's the gas formation reaction. We are not going to talk about acid-base reaction in detail. Later chapter covers acid-base. One of the ions can oxidize another, single dispersion. We're going to talk about single dispersion reaction. I'm going to start on oxidation reduction definition and continue from next class period. Let me finish this. We said there are 3 types of reaction based on reactivity pattern. One was precipitation. We talked about precipitation reaction, solubility rules, how we write down chemical equation for precipitation reaction. We also talked about little bit about acid-base reaction, general definition. Okay. Gas formation reaction. Not in detail. The third category is oxidation reduction reaction. As electrons are transferred from one compound to another. That's the characteristic of oxidation reduction reaction. Oxidation reduction is abbreviated redox, reduction oxidation. The definition of oxidation is loss of electrons. If atom loses an electron, that's oxidation. Reduction is gain of electron. How do you remember these two? Leo says Leo means loss of electron is oxidation. G means gain of electron is reduction. So normally in mnemonics helps you to remember. Leo says that. Leo means loss of electron is oxidation. G means gain of electron is reduction. You can tell that zinc metal here donate 2 electrons to copper 2 plus. When it gains 2 electrons, copper becomes 0. Copper is a neutral now. Now in this case, who's losing electron? Zinc is losing electron. Who's gaining electron? Can you tell me who's gaining electrons? Copper, right?
Mm-hmm.
So you can figure out which one get oxidized, which one get reduced based on loss of electron is oxidation, gain of electron is reduction. There are two compounds in a redox reaction. One loses electron, get oxidized. One gain electrons, get reduced. Reactant get reduced. It's the oxidized reactant. If something get help oxidizing, it is the reduced reactant that get reduced. I'm going to talk about that a little bit more. You guys come back and we will go over rest of the material in class on Wednesday. All right.
Okay. Thank you, sir.
Thank you for coming. Can you sign up the chat box?
Mm-hmm. Yes.
I'm going to stop the class. All right.